expression of simple quadratic expressions. Factorization of simple quadratic expressions. An algebraic expression is said to be quadratic if the highest power of its unknown is 2. I want to take that again. An algebraic expression is said to be quadratic if the highest power of its unknown is 2. Now let us consider the following examples of quadratic expressions. You can write them down for more explanation. Number 1, x squared plus x plus 12. X squared plus x plus 12. Number 2, 3b squared minus 5b plus 18. 3b squared minus 5b plus 18. Number 3, y squared minus 121. Y squared minus 121. Number 4, 81 minus 16b squared. 81 minus 16b squared. And number 5, x squared plus 2xy plus y squared. X squared, that is x raised to power 2, plus 2xy plus y squared. Explanation. In the first example, that is the x squared plus x plus 12, the highest power of the unknown is 2. And this is an example of a quadratic expression. In the first term, by the left-hand side of the expression, x is raised to power 2, and it is the greatest power that we have in that expression. So that is why that expression x squared plus x plus 12 is in quadratic form. In example 2, that is the 3b squared minus 5b plus 18. The highest power here also is 2. The first term has 3 and b squared. The second term has minus 5 and b. And the third term is plus 18. And on the whole, observe that the highest power of b is 2, making that expression to be quadratic in nature. In the third example, that is y squared minus 121. The first term by the left-hand side also has power 2. And of course, that is the highest power in that expression. So it is a quadratic expression. Again, this is a special case of quadratic expression, and we call it difference of two squares. It is because the last term can be replaced with 11 squared. That is, the last term, that 121, can be replaced with 11 squared, because 11 squared is 11 times 11, and it is 121. Thus, that expression y squared minus 121 can be read as y squared minus 11 squared. So we have two elements, y and 11, being squared under subtraction operation. And this is a special case of quadratic expression that is called difference of two squares. In example 4, 81 minus 16b squared is equally difference of two squares. This is because the 81 can be written as 9 squared, that is 9 times 9, which is 81. And that 16 can also be written as 4 squared, that is 4 times 4. Thus, 81 minus 16b squared can be written as 9 squared minus, open brackets, 4b close bracket squared, which is a quadratic expression because the highest second square there is 4b, all of which is raised to power 2. So that makes it difference of two squares. And of course, quadratic expression. The fifth example is x squared plus 2xy plus y squared. Here also the highest power of the unknown is 2. Though it occurs twice in this expression and on different unknowns. That is, you have x squared and you have also y squared. But on the whole, the highest power is still 2. This also is a special case which is called perfect square. This is because that x squared plus 2xy plus y squared can be written as open brackets x plus y close bracket squared. So it is in its perfect square form. Now let us consider factorization of simple quadratic expression. And we want to take the ones we call binomial terms. That is the ones with only two terms, binomial expressions. The first one that we want to consider, you can write this as example. Factorize x squared plus xy. Factorize x squared plus xy. Working. Line 1. X squared plus xy is equal to x, open brackets, x plus y, close brackets. I want to take that again. X squared plus xy is equal to x, open brackets, x plus y, close brackets. In the expression x squared plus xy, you can observe that it is made up of two terms. The first term there is the x squared term. The first term on the left side of that expression is the x squared term. And the second term is the xy term. The two terms are now being joined together with a plus. So it is a binomial expression. Each term is made of two factors. The x squared term is made of x times x. That is the x squared, meaning x times x. So two factors there. Then the xy term is also made up of two terms, x times y. So you have the x and you have the y in that term. The two terms have a common factor. Observe, we have x in the first term. We also have x in the second term. That type of factor is called common factor because it is common to both terms. So in factorizing that type of expression, we introduce a bracket and then write the common factor outside the bracket, while the remaining factors are grouped inside the brackets. I want to take that again. In factorizing such expressions, we have to take out the common factor outside the bracket, and then we group the remaining factor inside the bracket. That is why that line reads x squared plus xy is equal to x, which is outside the bracket, open bracket, x plus y. Then you close the bracket. So you see that the two terms inside the bracket are the remaining terms, making it to have two factors, the x factor and the x plus y factor. Note that in factorizing a binomial quadratic expression of the form ax squared plus b, there will always be a binomial factor, which is always being included in the brackets. Now I want you to take this homework and practice for this week. Number 1, factorize y squared minus 3y, y squared minus 3y. Number 2, factorize 5x squared plus 10, 5x meet again next week. Same time, same studio. My name is Asupo Yo. Bye.